Right, this question is from the 2015 PH4 paper. So it's an A2 question, and you'll see the second part that is a bit more demanding than probably what you'll be asked in an AS paper. But we've got a situation here. We've got disk A travelling at 0.4 meters a second. It's got the mass here is 0.36. Disk B is 0.18 kilograms, travelling in the opposite direction at 0.1 meters per second. So because we've got two directions here, remember that momentum is a vector, so the direction is important. So what we'll do is we'll define this direction as being positive. So in other words, when we put this value here into an equation, we'll have to put a minus on in front of it. Right, so I'll just scroll down just to get the question and the, so we'll scroll there. Right, so firstly we'll just write out our momentum equation. We've got A and B, so we'll call them mass of A, initial velocity of A, plus the mass of B times the initial velocity of B. The collision happens at the equal sign, if you like. So then the mass of A and the velocity of A after the collision is equal to the sum of the momenta afterwards is equal to the momenta before. And if you, I'll just scroll very quickly. Let's go back to the question. We've got this information here. I know it's not very, very prominent, but on colliding they stick together. So that means it's a totally inelastic collision. So let's get this back up. Oops, a bit too far. Hang on. About there, I think. So what we can do now, because we know that the velocity, because they stick together, VA is equal to VB, so we'll just call that V from now on. And we'll rewrite, so MAUA and MBUB is equal to M1 plus M2, because they're one mass effectively after the collision, times V. And we'll just put the numbers in here. So we've got 0.36 and it's travelling at 0.4. Mass of B is 0.18 kilograms, travelling at minus 0.10 meters a second, and that is equal to the sum of the masses, so 0.36 and 0.18, and the velocity, the unknown velocity, which we're after. If I put those in the calculator, what you get is 0.144 and minus 0.018 is equal to 0.54 V. So if we sort out the left-hand side, we get 0.126, that's positive, and 0.54 V. If this happened to be bigger than this one, then we'd get a negative here, which would give us a negative velocity, or a velocity to the left in the end. But as it is, it's positive, so we know that the final velocity is going to be towards the right. So 0.126 divided by 0.54, which is V, comes out as plus 0.23 meters a second. So that is 0.23 meters a second to the right. Right. I'll just pause for a second. So the final answer here was 0.23 meters a second. We'll be using that in the next part. So we need the kinetic energy lost during the collision expressed as a percentage of the initial kinetic energy. So we'll work out the initial kinetic energy first of all. EK before, let's call it. And remember that kinetic energy is a scalar, so the direction of the velocity now doesn't matter. There's no positive or negative, and in any case it's squared. So MBUB squared. So this 0.1 here, it's minus 0.1 times minus 0.1, so it's all positive anyway. So, but being a scalar, direction doesn't count in other words. So if I put the values in there, 0.36, so it's travelling at 0.4 squared, half 0.18, and the velocity is, well, I won't put the minus in there because, again, like I say, it's a scalar anyway. That works out as 0.0297 joules. Doing the same thing, EK after is half, the total mass is MA plus MB, because they're stuck together, and that V squared is the value that we've worked out here. I won't write in the numbers, so if you put all those in the calculator, you get 0.014 joules. So this is the energy after, that's the energy before. So the energy lost, the kinetic energy lost, is 0.0297, take away 0.014, and we get 0.015 joules. So that's probably as far as the question would ask you to go in an AS paper. But just to finish this one off, the percentage loss is going to be the lost energy, 0.015, over the initial kinetic energy, 297 there, and expressed as a percentage, just times it by 100, and to two significant figures, you'll get 52% for that one. Right.